Good morning, everyone. Hope all is well and everything's all right. Good morning, good morning. So, as always, give everybody a chance to get logged in and connected. Oh, how long? Okay, I think we're all in now. Okay, so last class we were in 4.2 and we did the regression line. So we're going to finish that up today. So remember last class, they gave us the information this way, gave us the pieces, correlation, um, the average and the standard deviation, or the mean and standard deviation of your explanatory variable, mean and standard deviation of your response variable. And then from there, we plug the stuff into the formula, plug the numbers into the formula. This time, we're just going to use the data set and then go to easycalculation.com and get our equations. So directions, first, we're going to find a regression line. Second, they want us to predict the distance the ball will travel when hit with a club head speed of 103 miles per hour. Then from there, determine the residual for the predicted value from the result in B. Is the distance in the table above or below average among balls hit at 103 miles per hour? So I'll give you guys a chance to write that down and we'll get rolling. All right, so let's go ahead and get to A. We want to find the regression line. So this is same information from that chart that we had before, club head speed and the distance. But for somebody who may want to copy it again or copy it for the first time, there we go. We're going to use this information and find our regression line. So we're going to type the data values in the same way we did correlation coefficient. And we took these data values and found our correlation coefficient for this data set. So we're going to do the same thing for the regression line. All right. So let's go to another page so I can show you guys. So just like before, type in what you're trying to calculate. It's the regression line. And then I put behind the easy calculator or easy calculation. And that's the first one that pops up. Like I said before, you don't have to use this website if you don't want to. If you found the app that you enjoy using, I think they even have an app for easycalculation.com. It's up to you what you want to use. Just make sure it's reliable. That's all. And make sure it's easy to use. So as long as all you have to do is type in your data values and hit enter, then you should be good to go. So let me go ahead and put these data values real quick. So should be as simple as that. You see our regression line right here. Also, they separate it. If MATLAB asks you separately what's the slope, it's always the number that's going to sit in front of your x or attached to your x. But that's right here. Notice it's right here as well. And then your y-intercept is the other number. That's right here, which is right here as well. All right. Any questions on using easycalculation.com or what I'm requiring of you? Notice I didn't take out the formula and plug it in and start writing it out. I didn't ask you guys to do that. You guys are not held responsible for effectively using the formula, but you are held responsible for having something reliable that can calculate this thing for you. Everybody good? Everybody good? All right. So once again, we had already talked about, I had my eraser on. We had already talked about how this was the explanatory variable, this was response variable. I was just re-emphasizing that. And so this is our regression line. Always make sure that you pay attention to MATLAB. Once again, just a reminder as to the positioning. You know, whatever's sitting in front of X, make sure you put stuff in the right spot. If they have it like this with the X, you know, just make sure you put numbers in the right spot. Also, make sure you hold true to whatever decimal place they're asking you to round to. So if they ask for 4 decimal places, use 4 decimal places. If they ask for 3, use 3. So make sure you hold true to that. And then also any signs. So notice 55 was negative, so it stays negative no matter whether it's in the front or in the back. So just make sure you're careful with the input of your data. Is everybody okay with A? Okay. So B, it says predict the distance the ball will travel when hit at a club head speed of 103. So if we're going to use the regression line to predict, we'll take the value that they give us and plug it in for X. And so 3.166 times 103 minus 55.797, that will give us the prediction of 270.3 yards. Oh, no worries, no worries. Not a problem at all. All right. Any problems with the prediction? So the regression line predicts that if you hit the ball at 103 miles per hour with a club head speed of 103 miles per hour, then the ball will travel 270.3 yards. Okay, so that's the purpose of the regression line, to make these predictions based on previous observations. So it's something that most definitely you could logging out. Okay, cool. Thanks for letting me know. So it's something that you most definitely can use in business, or if you want to predict, maybe you had an event and for some years now you want to predict that how many people would come out. You would take observations, stuff like that. Just have to have two variables. So now this last one, C, determine the residual for the predicted value from the result in B. Is the distance in the table above or below average among balls hit at 103 miles per hour? So we have this predicted value of 270.3. Now to find the residual or error, remember we talked about that last section, and I said it was going to come back. The residual and error are the same thing, just two different ways of talking about the same thing. The way you would calculate it is by taking your observed Y minus the predicted Y. So if you do not have an observed Y, you cannot find the residual. Okay, so you need your observed Y. In other words, you need to have hit the ball at 103 miles per hour in order to be able to find the residual. And when you go back to the chart, you see that there is an occurrence at 103 miles per hour. All right, so take your observed Y minus the predicted Y. And this right here is just a symbolism for the two, Y minus Y hat. 274 minus 270.3. It's right here. I said got that one from the one from the chart and then the one from the equation. That's another way of looking at it. And that's 3.7 yards. And so this observation in the chart is above average balls hit at 103 miles per hour. And you see in the purple I wrote, it's above because it's positive. Now, if it ended up being negative 3.7, then we would have said the observation was below average balls hit at 103 miles per hour. All right. Questions? Any questions? All right, everybody good? See somebody in the chat? For the residual, yes. You're trying to find a residual? Yep. All right, is everybody okay before we go to 4.3? Let's scroll up. Well, 4.2, remember we did part of 4.2 last class too. So, but yeah, man, chapter 4, it's not that heavy. It's not gonna hold you for so long. Yeah. And that's what I was talking about as far as content. Now, it may take more for you to actually do the problems, but as far as content and me lecturing, it don't take that much, So that's why I was trying to make sure you guys, try to warn you guys to stay on top of this stuff and make sure you're knocking out this math lab work at a decent pace. Because like I said, before you know it, we'll be sitting in chapter 7. You'll be like, hold on, man, what's going what's going on? So yeah, so that's why I was trying to, make sure that we keep this thing in perspective. So here we're looking at 4.3, and 4.3 is short as well. So it's the coefficient of determination. It measures the proportion of total variation in the response variable that is explained by the regression line. It basically tells you how reliable the regression line is. Mhm. It is the correlation coefficient squared. The symbol for it is capital R squared. And it is between 0 and 1 inclusive. So if the coefficient of determination is equal to 0, the regression line has no explanatory value. If it's equal to 1, the regression line explains 100% of the variation in the response variable. All right, everybody good before we go to the example? All right, so determine and interpret the coefficient of determination for the club head speed versus the distance. So we're still dealing with the same information from the golfer, all that good stuff like that. All right. So first thing we need is the correlation coefficient. Remember, we already found that to be R equal to 0.939. So once again, easycalculation.com is where you would do that. Take your data information, your data set, plug in the information. Then we're going to square it. So that's 0.882, which would be 88.2%. So I need a chance to write. All right, so let's look at the interpretation. 88.2% of the variation in the distance in distance is explained by the regression line. So that's what this means for us. Subtract that from 100, that means 11.8% of the variation is explained by other factors. So you're talking about other factors like, the wind, maybe the person twists their hips differently than they normally twist or something like that, hit the ball wrong. That's stuff that cannot be explained by other, by the regression line. So the regression line just goes off of normal observations, normal occurrences when that person hit the ball. So basically says that the regression line has an 88.2% reliability. All right, any questions, concerns, comments? All right, so everybody good. So let's get into what you guys are going to be held responsible for up to this point. So we've done all of chapter 4 now. So you have homework 1 through 4. If you have not turned the definition, I think everybody has, but it's just up here as far as what you guys are held responsible for to this point. And now you have test 1 and test 2 that should be available. I need to check and see if I posted this. I think I did. But this is all that you guys are held responsible for to this point. Now, assignment 1 and assignment 2, need you guys to go ahead and take a look at those. Next class will be a review day, but it's up to you guys to bring whatever questions you want to bring to the table. I will not bring questions. That's the way I handle review days. I expect you guys to at least go into Math Lab and see if you have any questions. Take a look at the test reviews, see if you have any issues with it. Take a look at these assignments. And so just to remind you where they are. That's probably gonna put me in the textbook. Hold on. All right, so your assignments are over here. Got assignment 1 and assignment 2. So that's 3 problems right there. 1, 2, 3, 4, 7 problems right here. So it's only 7 problems. All of them are odd. All of them are in the back of the book, so you can check your answer. And I expect you to check your answer so you know if you got the answer correct. And then from there, it's just like just a little gauge to let you know if you know what's going on in these 2 chapters. So that's what that is. Somebody say something. Now, in the book, yes, they're in the ebook, but you would go to these pages for the problem. Now, if you want the answers are in the back of the ebook, right? But you actually go to these pages to get those problems. All right. And so before we talk about due dates or anything, is everybody okay with what we're talking about right here? These 7 problems, assignment 1 and assignment 2. Oh yeah, most definitely. Do whatever it takes to get those answers. It's something I would probably expect you guys to, do in a notebook, or maybe if you're doing it electronically, doing it on your screen or whatever. Yeah, whatever it takes to get those answers. Yep, do whatever it takes to get those answers. If it takes work, some of it may take work. Like remember when we were dealing with the quartiles and stuff like that, listing out your data values from least to greatest. Making sure you know how to do that. There are things that can help you find those as well. But I do want to see as much work as possible. But if you're using certain technologies, just like I just finished showing you the regression line and the correlation coefficient, I told you not to use, anything but an Apple website. So it wouldn't call for any work there. So just certain things are going to call for you to write some stuff out. Certain things may not. But the goal is to make sure you understand how to get these answers. All right. Questions on that before we go back to thing? All right. So let me see what chapter is this for. 7. Yep. Also. All right. So this is this. So I'll give you guys a week to get that to me. So do 2/9, February 9th. That's the whole week. Now, if you think you may want to have if you want to ask questions about it, then I would suggest you take a look at them over the weekend. Because some problems, truth be told, it shouldn't take a week to knock out these 7 problems, right? Especially when you got the answers in the back. But you do want to make sure you check the answers to see if you know if you got the answer correct. And you would just submit them to me the same way you did your definition by shooting to me in an email, or something like that. Scan and email me. Some people shot it to me through Canvas. All right. Questions. So next class, like I said, is a review day. My goal is not to do anything new. So if you guys don't come with any questions, it'll be a very short class. Everybody good? Everybody straight? Everybody understand? Everybody all right? All right, sounds good. Appreciate it. All right, so you guys are good. I'm good. Have a great weekend. Be safe. And I will see you next class. Looking to review. And this is from anything from whether you might have questions on chapter 1, chapter 2. Anything up to this point, if you have a question on it, feel free to ask it on next class. Thanks, appreciate it. You guys take care.
Sorry, Professor.
Thank you. Yes.
I sent you an email last night. I was just wondering if you got it.
Oh, well, shoot, if you sent that thing last night. Let me
Sorry,
see.
probably kind of late.
Let's see. Why did my thing go back to Chin? Let's see. Megan Chin.
Lauren Zugary.
Yeah, I don't see. You know what? Yeah, because Megan Chin sent that this morning. I was looking at the wrong day. Okay, I got you. I got you.
Okay,
So,
awesome.
so did you want me to respond to that now, or just respond in the email?
As whenever you can. It's just kind
Okay.
of regarding future like class dates and stuff and assignments.
Okay. Okay. Not a problem. Mhm.
Perfect. Thank you.
Thank you. Have a good one.
You too.
Okay. Mhm.